welcome to the Centremaps video. Today we're at the BGS headquarters and lucky enough to have Russell with us, talking us through the civils data, the BGS Civils, and actually resistivity as well. So Russell, yeah, the civils, what was the background?
BGS Civils started as a project for a set of utility companies, power companies. It was really this idea of moving away from a standard geology map to something which was catering more for people with an engineering background who need to understand the ground engineering capabilities of a site they might be developing. In the UK, you have to do a ground investigation before you start building things. It's a requirement. There are BS standards for building things. So it seemed logical for us to take a standard geology map and tweak it to provide, if you like, an advance warning or a heads up to specialists in the field saying, this part of the country has some unusual geology, you might need to think about these features before you start your ground investigation. And so it's there as an aid memoir. It's also there to help specialists who might want to look at different territories to move into. So you might have an organisation who really understands their local area, but they want to expand into, say, a different part of the UK, and they might not know the geology from their own background as well. It kind of like gives them a kind of like an advanced view of there are some issues here you need to think about before you start designing your ground investigation, and then they can go and check whether those things exist as part of their test. It's a geology map, but it's been simplified to a degree. We just provide one layer. There's no 5 layers that you get in BGS geology. It's a single layer. It's kind of like looking at what happens in the uppermost 3 meters. So the 3 meters you're most likely to dig into for foundations or infrastructure. And it is using the borehole data that people use all the time, those free resources that we offer include all this borehole data, and some of the engineering data that we've either got from our own labs here at the headquarters or has been donated to BGS through engineering companies. And all we're doing is providing simple summaries of engineering characteristics. The most popular components, there are 9 components in civils. The most popular ones are strength, self-explanatory, how strong are the rocks that you're looking at, and strength varies a lot as you go deeper. So it's a ballpark figure so people don't turn up surprised. They're kind of like, right, this is a slightly weaker set of rocks in this area. I'm going to plan for that. So strength is the first one. The next one that we find people use a lot are what we call discontinuities. So these are the ways rocks and deposits will break up. And that's quite important. If you need to move materials around, you sometimes have to rely on the natural ability of a rock to fall apart and break apart. Obviously, that means from strength and discontinuities, you can look at excavatability. So the costs of moving materials around is quite important. You need to understand. And if anyone's ever dug a hole in their garden, if you dig a hole in the ground, you get what's known as a bulking effect. And you can't always put it back. So we have a very simple bulking model so people can understand that if you're digging lots of foundations, you might have material you need to get rid of afterwards, and that can be quite a lot. And if you haven't factored that into your site operations, that can get very expensive. So they're the ones that get used a lot. But we've also included additional data sets in there, which are more about again, it's a little bit like a hazard. So there's corrosivity. So if you're putting metalwork into the ground, and it is ferrous corrosivity, but we also have a layer called sulfates and sulfides that is very popular with the engineers, and that warns them the presence of sulfates and sulfides in rocks and soils can cause a problem if you're using certain types of cement, and also you need to handle those materials quite carefully because they don't like being exposed to air, they don't like being wetted and re-wetted, so there's all kinds of little things in there they need to think about as part of their plan for when they're working on site. More recently, the most popular layer has been resistivity, which simply describes the resistivity of the ground in that shallow zone. And as more people buy electric vehicles, as we are changing our energy infrastructure to have different networks, understanding the resistivity of the ground really helps for people who are planning to put in transformers or new cables or trying to earth electrical systems they've currently got. So that's quite a useful data set for specialist organisations who want to know how current flows through the ground, basically. So Civils is designed to be an aid memoir or a heads up for common ground conditions that people need to think about when they're building houses or infrastructure or some kind of utility.
Yeah, and okay, so it gets away from perhaps the talking about a rock type to talking about properties and ways to
That's a key thing, as I think we mentioned in one of our other videos. The lexicon's a great resource. It tells you all about a rock name, but it is a local name that describes a rock type, and people don't always know how to interpret from a name into properties. And so civils is one of those that kind of like translates a little bit of the engineering, just a little bit, not a lot, but enough. And as I say, it's 9 components. The other components are foundation conditions and foundation types. And there's also one which is quite useful for the infrastructure sector. There's a layer which is set up using what's known as Highway 600, which is a manual for what you can do with spare material. Can you use it for embankments, or must you not use it for embankments? So there's a little bit of information there which is about, can I get onto a site? Can I dig this site? Can I move this material around? Is there anything I need to be aware of? If I need to get rid of this material, what can I do with it, basically? So it's a bit niche, it's a bit specialist, but it will aid most developers and certainly planning.
And resistivity used to be a part of the civils, but it's now sort of in its own right as a...
It's always been slightly separate to civils because it was developed in a very different way. It was developed for the power sector. We've put it in with civils as part of its bundle because very few people build infrastructure without some kind of power connection. And virtually everything is censored. Virtually everything has got some kind of electrical component to it.
Talking earlier, the electric car network, there's challenges, let alone whether there's enough power in the network to power a site, the actual ability to...
One of the drivers for the resistivity data set is we're making fairly significant changes to how we generate power, how we move power around, and how we use power. And you can't just put high power equipment everywhere. You do have to think about what you're doing. There's a safety issue in terms of what you're putting onto the ground and into the ground and how people are using it. So it makes sense to understand the ground before you start putting very expensive electrical equipment in. And so there's all kinds of, there's market forces in terms of where people want to charge their cars, but there might be some physical limitations for how many chargers you can put into a certain part of the ground. So it's about striking a balance between how much infrastructure you can put in and how easy it is to put in. One of the drivers for the resistivity model was there might be an area which is only 100 metres down the road, which is much more suitable for putting in a large bank of EV charge points, rather than a very highly resistive lump of rock, which is difficult to work with.
Right.
Here, you could just go a few hundred yards down the road and have a much easier installation and a lower installation cost.
So actually, even if you're just thinking about a reasonably large site, just thinking about the position within that site.
Again, because geology changes a lot, and because resistivity is a function of clay content and moisture and temperature, you can imagine almost any site in the UK where it'll be slightly different for moisture or slightly different clay content. And it's kind of like fairly self-evident on a large site. There will be more advantageous and less advantageous areas. Obviously, it's not difficult to put these things in. You can always put these things in. This is something we're always keen to get across to people. Geology shouldn't stop you from doing what you're doing. You just need to be aware that there are advantageous areas and less advantageous areas, and it's about how much money you want to spend or not spend.
Yeah. And again, I probably say this, most videos do, this kind of information is worth considering earlier on. And
yes,
actually,
yeah. The way we've always described civils to people is it's one of those sets of data that you look at over a cup of coffee first thing on a Monday morning when you've got to decide, are we going to bid for a job? Are we going to work in this particular area? A quick look at the geology map, a quick look at civils, and you can start to make that plan.
We had a video previously talking about the 50k geology, and it's really good to understand going from the rock types. It's kind of information that's more meaningful to the user, isn't necessarily a geologist. May want to work with geologists later in the project, but can clear that first stage. And if you want to take a look at the data sets, there's samples on the site, plenty of information, obviously the BGS site as well, plenty of supporting information there. And any questions, any sites you're interested in and want to talk through, let's just get in touch. Otherwise, thanks for watching the video, and thanks, Russell.
Thank you.